This week's notes is on operations with real numbers. And I would recommend that as we go through these notes, you have your notebook open because there may be times where I do go to a blank screen and add some additional notes for those who need it. So at this time, I will wait for a second to make sure you all have a chance to take out your notebook, put today's date upper right corner, and the title, Operations with Real Numbers. And if you move to take notes off to the side, you can either quickly rewrite the question or just put number 1. So if we add notes for number 1, just write number 1 in your notebooks. Okay, so for number 1, we are going to rely on PEMDAS. Notice that this expression here just has subtraction and addition, which means we will work PEMDAS using addition and subtraction mentally left to right, following what is here. So the first piece we're going to work with is negative 5.4 minus 3. So off to the side, we can say negative 5.4 minus 3. Writing that 0 is completely up to you. If you don't, just make sure you are aligning the whole number 3 right underneath the 5. When we subtract that, we will get negative 8.4. We got that by knowing that when we add two negative numbers, we really can just see this as addition because we are subtracting two negatives. So 4 plus 0 is 0, 5 plus 3 is 8. Adding two negative numbers, we get a bigger negative. So now I'm at negative 8.4. Technically, I now need to do negative 8.4 minus 12.1. This setup really isn't going to help us much. So we can realize, this is plus. Negative 8.4 plus 12.1. So again, still, this setup is really of no use to us because we have negative 8.4 plus 12.1. If this had been the negative that I had there at first, it wouldn't be so bad because we could literally just treat this entire question as addition and then add our negative. But that's not what we have here. We have a negative 8.4 plus 12.1. My recommendation is to realize that you can actually rearrange this to be 12.1 minus 8.4. Negative 8.4 plus 12.1 is the same as writing 12.1 minus 8.4. Notice here it was a plus 12.1. This 12.1 is positive. Negative 8.4, we're saying minus 8.4. So now we can do our subtraction. 1 minus 4, can't do it. So we'll cross off the 2 and write a 1. This 1 becomes 11. 11 minus 4 is 7. The decimal drops. Now we're working on 1 minus 8. We know that we can't do 1 minus 8. So we are going to cross off this 1, write a 0. This 1 becomes 11. Now we have 11 minus 8, which is 3. And we are done. The answer for this question is 3.7. So again, the strategy, first work with the first piece, negative 5.4 minus 3. That's a negative, and I'm subtracting, so I will get a larger negative number. We then had to work with negative 8.4 plus 12.1, but instead of trying to work with it written this way, we rearranged it to be 12.1 minus 8.4 and arrived at 3.7. Let's talk a little bit more about our adding and subtracting rules. Now, there are some of you who are very comfortable with this. You may not need these additional notes. But this is a place where I do plan on adding some notes off to the side. What I'm able to fit right here, if you write small, I would recommend doing notes here. Otherwise, make a note in your notebook that we are going to take notes on number 2. So when we are adding two negatives, adding two negative numbers, a process that you can follow: first, ignore the signs. So ignore that they're both negative. Ignore signs and add the numbers. I'm just going to put and add. So ignore that they're both negative and just add. So let's apply that to this first example. I have negative 51 plus a negative 26. Realize that that would have been the same as saying negative 51 minus 26. They're just providing a different notation here. So we're going to ignore the fact that these are both negative and literally just add them. So 51 plus 26 is 1 plus 6 is 7, 5 plus 2 is 7. Once we've done that, we are now going to make the result negative. So my answer is negative 77, and I'm done. So when you're subtracting two negatives or adding two negatives, this is the same. Negative 51 minus 26, negative 51 plus a negative 26, say the same thing. I have two negatives. So treat it like addition and then make your answer negative. For the second one, we are adding a negative number and a positive number. Rules are changing a little bit on this. We're still going to ignore the signs. But this time, we're going to ignore the signs and subtract the smaller number from the larger number. So let's see what that will look like. Here I have negative 33 plus 26, but we're going to ignore the signs, and this is going to become 33. Well, let's see, ignore the signs, subtract the smaller number. So 26 is the smaller number, so I'm going to subtract 26. Let's do it. So 3 minus 6, I can't do it. Cross the 2 off. This becomes 13. 13 minus 6 is 7. 2 minus 2 is 0, so I have 7. To finish this, you are going to keep the sign of the bigger number. I'm going to put bigger in little quotes because it's going to be an unofficial word. We'll talk about what it means in a second. So if I look, here's negative 33 and here's a positive 26. 33 is bigger than 26, so that's how I know my answer is negative. So to recap, we ignored the signs. So mentally I said 33, 26. No negatives, no positives, just 33, 26. Subtract the smaller number. In this case, 26 is smaller than 33. So we did 33 minus 26, and we got 7. To decide if this was supposed to be positive or negative, I looked just at the numbers. Again, so 33 compared to 26. Well, 33 is bigger than 26. 33 is negative, so my answer is negative. On to number 3. So here I have a whole number times two fractions. The strategy here for number 3 is to turn 4 into a fraction. And we're all pretty comfortable with knowing that 4 can be written as 4 divided by 1. And then I still have this. You could keep both of these negatives, but we know negative divided by a negative is positive, so I can choose to write that as 7/3. And then finally 6/5. What's great about multiplying fractions is we do not need common denominators. We can just multiply straight across. But since we can't use a calculator on this, let's first see if there's some simplifying we can do. So when I look for, neither of these is divisible by 4, 7 in the top, none of these are divisible by 7, 6, check the bottom, no, but when I look, 3 does divide into 6. So 3 divides into itself once and into 6 twice. Don't be tempted to do something with 4 and 2. They're both in the numerator, so there's nothing you can do. So when I look top and bottom, nothing else I can do. It's possible that the question in your problem set or the question in your quiz on Friday will have another canceling ability, but this one does not. So now we're ready to just multiply. When we do that, I would recommend seeing this as 4 times 2 is 8, and then 8 times 7 is 56. So again, we do 2 times 4 is 8, times 7 is 56. In the denominator, 1 times 1 times 5 is 5. This does not end in a 0 or a 5, so right away I know I can go no farther. My answer is 56/5. Very good. For number 4, let's talk about rules when we are multiplying and dividing with negatives involved. So let's write down a couple notes. When multiplying or dividing, ignore the signs. And do operation. Once you've done the operation, and we'll look at what that means in a second, there's a couple little key phrases that can help. Same, sign, sum. What that means is, if I'm multiplying or dividing two positives, the answer will be positive. If I am multiplying or dividing two negatives, these are still the same sign. The result will still be positive. I'm going to write that a little different way. So if I have a positive times a positive, or positive divided by positive, or negative divided by a negative, negative times a negative, the result is positive. The other side of this is different sign difference. And difference means subtraction or negative. So what do we mean by that? If I am multiplying or dividing a positive and a negative, or a negative and a positive, so different signs, my answer will be negative. So let's put this into practice on number 4. We're going to ignore the fact that this is negative and just do 32 divided by 8. We all know that 32 divided by 8 is 4. Now we look at the signs. Are these signs the same or are they different? Well, one is positive, one is negative, different. So different signs, difference. My answer is negative. In the second example, ignore the signs. So don't think of this as negative, don't think of this as negative. Just do the operation. 4 times 7, 28. Now I look at the signs. Both are negative. That means that they are the same sign. Negative and a negative, when I am multiplying or dividing, the result is positive. My answer is 28. If you have your own way of just seeing it and knowing that this is negative 4, seeing this and knowing it's 28, no problem. But here is a concrete mental conversation you can have when you're making your decisions. Very good. Let's go on to number 5. So in this week's assignment, we are bringing back fractions. We did work with fractions earlier in the year, and they're coming back now. As we said before, multiplication, really nice. I first do want to check if there's anything I can simplify. These are not divisible by 2. Nothing up here is divisible by 7 or 5. So we can just multiply straight across. So multiplying straight across, negative 2 times 1 is negative 2. 7 times 5 is 35, and I'm done. But be careful, because I could have a number 5 that looks like this. So here's another example. What if we had 3/8 times negative 1/3? Well, here I can do something with these 3's. 3 goes into itself once. 3 goes into itself once. Now when I multiply straight across, I will be doing 1 times a negative 1 is negative 1. And in the denominator, 8 times 1 is 8. So really make sure before you just go ahead and multiply, we check to see if there's any simplifying that can happen. And once you simplify, we still go back to just multiply what's in the top together, multiply what's in the bottom together. Number 6, we are back to PEMDAS. So off to the side, you can make a note. Follow PEMDAS. Notice multiplication and division are on the same level, addition, subtraction on the same level. So if something just comes down to these operations, go left to right. If it's just addition and subtraction, left to right. So let's see. I have subtraction and I have division. Division comes before subtraction. So we will do this piece first. We're going to leave the 20 alone, and this minus is also still here. So this piece right here, we didn't touch. We are just working on the negative 15, just working on the negative 15 divided by 5, which is negative 3. So this becomes 20 minus negative 3. Subtracting a negative becomes addition. My answer, 23. Coming back to fractions in number 7. As soon as we're talking addition and subtraction, make yourself a note. Adding or subtracting fractions need common denominator. So when I ask myself, I have a 4 and I have an 8. Well, my common denominator has to be at least 8. And what's really cool is that I know I can get this 4 to be an 8 if I multiply by 2. And if I multiply the bottom by 2, I have to multiply the top. So in this example, we actually get to leave this fraction alone because my smallest possible common denominator is 8. And I can make that happen just working on the first fraction. So when we multiply 2 times 1, we get 2. 2 times 4 is 8. Didn't have to touch the second fraction, so we just bring that over. Leave the denominator alone. 8 is not going to change. We're just going to look at subtracting what's in the top. 2 minus 3 is a negative 1 divided by 8, and we're done. There may be a question that comes up in the set or on the quiz that we do need to modify both fractions to get common denominators. So at the bottom of your paper, let's look at second example for number 7. Let's work on negative 1/4 plus 4/7. So there's nothing I can multiply 4 by to become a 7. Then we need to ask ourselves, what's the smallest number that 4 and 7 divide into? My answer is 28. So my least common denominator, LCD, least common denominator, the smallest denominator that will work is 28. For 4 to become 28, we need to multiply by 7. Now if I multiply the bottom by 7, I need to multiply the top. For 7 to become 28, I need to multiply by 4. So we will be multiplying by 4 divided by 4. This will become negative 7 divided by 28 plus 16 divided by 28. And I'll pause there for a moment for you to really look at what we just did. I am multiplying the first fraction by 7 divided by 7. I am multiplying the second fraction by 4 divided by 4. But what's cool is if you ask yourself, what is 4 divided by 4? It's 1. So you're really just multiplying this by 1. Over here, 7 divided by 7 equals 1. You're really just multiplying this by 1. But now I have the common denominators I need, so we can work on negative 7 plus 16. What is negative 7 plus 16? If you say 9, you are right. So 9/28 is my answer. And I checked. The only factors of 9 are 9 and 3. 28 is not divisible by 9 or 3, so I know I'm all done. Very good. Let's come back up to number 8. We know 1 minus a negative 11 will become 1 plus 11 equals 12, and we're all done. Here we're back to a negative, and we are subtracting. So I know this will become a bigger negative. This is another example where we can ignore the fact that they're both negative and just add. So 44 plus 41, 4 plus 1 is 5, 4 plus 4 is 8, and now we make the answer negative. And we're done. On to number 9. Number 9 is the only kind of real-world scenario that will be in this problem set. Number 9 says, the table gives the temperature in degrees Fahrenheit in 5 cities at 6 a.m. on the same day. So it's pulling this data. At 6 a.m. in Boston, it's negative 7. In Nome, Alaska, negative 25. Springfield, 37. Orlando, 63. So all of these are at 6 a.m. Use the table to answer the questions. Question A, how much lower was the 6 a.m. temperature in Winnipeg than in Orlando? When you see how much lower, highlight that or put it in a box. How much lower means subtract. And if we read this again, how much lower was the temperature in Winnipeg than in Orlando? So this is where I start. So I know Orlando is 63 degrees at 6 a.m. and Winnipeg is negative 14. So we are going to subtract 63 minus negative 14. We know that minus minus turns into addition, so 63 plus 14. If it helps you to line that up to add it, 3 plus 4 is 7, 6 plus 1 is 7. So my answer, 77 degrees Fahrenheit. The answer is, how much lower was it in Winnipeg than in Orlando? It's 77 degrees lower in Winnipeg than it was in Florida at 6 a.m. And I know it might be like, well, you just said subtract, but this was adding. But that adding came from subtracting a negative. So here we did subtract. Question B says, by noon, the temperature in Nome had risen by 12 degrees Fahrenheit. So this is given to us as a fact. The question is, what was the temperature there at noon? Risen, when something rises, it's getting bigger. So we are talking about addition. So if you see the word risen, it means we are going to add. What do we know about Nome? Well, at 6 a.m., Nome was negative 25 degrees. We need to add 12. So what we're really working on is negative 25 plus 12. So this is an example of ignore the signs, because we have a negative and a positive. So what we're going to actually do is ignore the signs and subtract the smaller number. Five minus 2 is 3. 2 minus 1 is 1. To figure out if this answer is supposed to be positive or negative, we come back over here and ask ourselves, which is the, and I still put it in kind of like air quotes, bigger number. And by that I mean, don't look at the negative or positive. 25 is bigger than 12, or is 12 bigger than 25? Well, 25 is definitely bigger. 25 is bigger, 25 is negative, so my answer is negative. The answer is negative 13 degrees at noon. So at 6 a.m. in Nome, it was negative 25 degrees. Now by noon, lunchtime, it's up to an incredibly warm negative 13 degrees Fahrenheit. Number 10. Take a second to look at what's the difference between this one and this one. If we look at the location of the negative, here the negative is inside the parentheses, and here it is outside. That is going to change things. When it is included inside the parentheses, it's going to be included in what we write. So we're going to write negative 3/4 times negative 3/4. We write it twice because the exponent told us to. Negative 3/4 all squared, we write it twice. Now we multiply. Negative 3 times negative 3, 9. 4 times 4, 16. Can't simplify any farther, so I'm done. Here, the negative is outside, which means it is literally going to be left out. That negative, or that negative 1, however you choose to write it, stays outside. And ask yourself, how many 1/4 are being multiplied? This exponent tells me 4 of them. So 1/4 times 1/4 times 1/4. One more. Now this is still a no calculator question, so we need to know how to do this multiplication. Our answer will definitely be negative, right? Because this is still up front. So let's work it out. 4 times 4 is 16. 4 times 4 is 16. And now I can actually work on 16 times 16. 6 times 6 is 36. 6 times 1 is 6. Plus 3, 9. Now we move over to the 1. 1 times 6 is 6. 1 times 1 is 1. Add this together. I bring down the 6. 9 plus 6, 15. Carry the 1, 256. So my answer, 1 times 1 times 1 times 1, negative 1, divided by 256. So on number 10 in your assignment and on the quiz, when you see this question on the quiz, pay attention to whether or not your negative is inside or outside, parentheses. Number 11 is a classic evaluating question. So I'm asked, evaluate the expression when m equals negative 2. So this means wherever I see m, I'm substituting in negative 2. So this will become negative 2 squared plus 9 times negative 2 minus 8. Notice how careful I was to make sure I used parentheses when I substituted in my negative. Now we just need to figure out what this equals. So negative 2 squared is 4 positive 9 times negative 2 minus 18. Bring down the minus 8. We are down to subtraction here, so we're going to work left to right. 4 minus 18 is negative 14, minus 8, negative 22, and I am done. So the key here is to remember when you're down to just subtraction or addition, we really have to make sure we work left to right. Otherwise, things could go wrong. Number 12, 100% PEMDAS. In number 12, if you want to make a note, all of PEMDAS is used here. We're going to use every single letter in PEMDAS. All of PEMDAS is used on this example. So off to the side, PEMDAS, well, parentheses is what the P stands for. When I look for parentheses, I'm looking for sets of parentheses that inside there's something I can do. And when I look, I can definitely do something with this, and I can definitely do something with this. Everything else we're going to leave alone. What I mean by that is that this negative that's out front, it's going to stay out front. 2 minus 4 is negative 2. The square is still there. Plus, inside these parentheses, 2 times negative 1, negative 2. This cube, or the 3, the exponent, 3 is still there. So we just dealt with parentheses. Next comes exponents. So again, this negative is still going to be out front. Negative 2 all squared is 4, plus negative 2 to the third. If you're not sure, make a note. Negative 2 times negative 2 times negative 2 is what this means. So negative 2 times negative 2 is a positive 4 times one more negative 2, and I have a negative 8. We're down to just addition. Negative 4 plus a negative 8, negative 12, and I'm done. So this is not bad as long as we're very careful with how we use PEMDAS and respecting parentheses all the way through. Number 13 is a nice little step back into just some basic adding and subtracting. I'll leave that up just in case someone's still writing. 2 minus 4, negative 2. Negative 2 minus 2, negative 4. And if anybody needs help breaking down these a little more, let me know. But I think we should be comfortable with what we just said. Number 14. Let's take a quick little note over here. When there's a negative base, we have 2 rules we need to follow. If I have a negative number raised to an even power, so a negative base, a negative number here raised to an even number, my answer will always be positive. If I have a negative number raised to an odd exponent, the answer will always be negative. And let's see how this works out in number 14. So in number 14, I have negative 3, which is a negative base, raised to an odd number, 3. Right away, I know this is going to be negative 27. And the reason I know this is because I know these rules. What this really means is negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3, that is a positive 9, but I still have to multiply by one more negative 3, and that's where negative 27 comes from. Negative 6 all squared is something we're definitely more comfortable with, we know negative 6 times negative 6 is a positive 36. But notice how well this fits into our rules here. I have a negative base, negative 6, raised to an even number. 2 is an even number. So therefore, my result is positive. Last but not least, number 15. Just a little practice in notation, recognizing that this is the same as saying negative 1 minus 5, which is negative 6. Six plus a negative 6. Adding a negative is the same as subtracting, so that's the same as saying 6 minus 6, which equals 0, and we are all done. That is our problem set for the week. Go ahead and reference these notes at any time online. Again, the website is https forgot my backslashes. https : 2 backslashes or forward slashes, however you see them. The slashes that go this way. Math with Miss J. .weebly.com, and when you go to the website, look for the Topics tab. It's on the left side. Click on that tab and you will get to the videos. Have a great day.